Hi everyone, welcome to today's OTT. Today we're talking about working with generative AIs in AWS. It's a very hot topic, so let's get started. In today's OTT, we have a little bit of story time, the background around AWS Bedrock. It's a new service that allows developers to leverage AI, and in specific, generative AI. And we're going to talk about different use cases where we can apply this new technology. And we're going to have a hands-on where we're going to explore two different POCs, and we're going to see integrations and how we can use in practice this new service. So what is AWS Bedrock? It came out this year. It was first announced in April and made generally available in September. AWS has the description for the service as the easiest way to build and scale generative AI applications with foundational models. And I would highlight the foundational models part. These are the foundational models available today. They are from Amazon themselves, Meta, and some other startups. Each one has its own characteristics, and we can take a look deeper into them to see which one works best depending on your use case. Now, this Bedrock service comes in a time where the AWS ecosystem already has a variety of AI services. It has Transcribe, Poly, which is natural speech from text. It has Amazon Translate, Amazon Recognition, and you even have Amazon SageMaker, which is used to build more complex and fine-tuned models. So how does AWS Bedrock fits in this already existing ecosystem, being such a new service? I think it fits on the slide we saw before, where we say that it's the easiest one to work with generative AIs, because now you will see from the POCs that we are able to very quickly prototype generative AI solutions. Compared to before, that would not be possible. Let's say you use SageMaker, you would have to train a model, and that would be somewhat expensive. And with the pre-trained foundational models, you can skip over to that part. And you might think that you're going to get some bad models, but AWS also provides the knowledge base extension service, which is basically a way to allow the foundational models to have more context about your problem. So this knowledge base connects Bedrock with a vector database, and you can use that to, in a way, fine-tune or give it more context, but you can also fine-tune and create your own custom models, but that will affect the pricing. The pricing will be per token, the same as other AI startups provide, but you can also provision this pricing to reduce your cost. And let's take a look at the hands-on that we have in the POCs I've built for you. The first one is showing how we can integrate Bedrock with other services. In this case, we're going to be integrating with S3. So let's see. Can you help me come up with some example? And here we have industry, and we have a company name. I've done a couple examples that I'll show you. I've done a gold mine, a mining company, an IoT company, a marketing company. Can anyone in the chat provide me with some examples, some industry that you can think that comes up to your mind that we can use to put it here? Health. Let's try that. Let's say that the industry is health. And let's say company name, I guess it can be myhealth.com. And let's see what happens. We start this execution. So right now we're working with step functions and we're generating a payload. Let's see if this is going to work. We're generating some stories. And at the end, we're putting an object in S3. So the result should be that here in S3 now we have the myhealth.com And if we take a look at what's the result, you see that we have some stories. So today, John Smith met with a patient who's suffering from high blood pressure. So besides John Smith, you can see we have Bob, Jane, Alice, Eve, and they're all from different, they all have different positions, and we can inspect what this state machine did. So let's take a look here. The input industry, the output. So the first thing that it did is generate a list of people with jobs. And this is kind of the potential of these generative AIs. It may not always be truthful, but it's pretty good at imagining new things and generating mock data or data you might use for different things. You have an occupational therapist, physical therapist, pharmacist. And even though the model is communicating with us via text, if you provide a prompt that is detailed enough, such as this one, I asked it explicitly to provide me with a mock JSON with 5 items and 2 keys. That was enough context for me to get a JSON, and using the step function string to JSON, I was able to create an object and then map, iterate. And for each one of those people that it created, I asked it to create some common activity that that person might have done in their job today. So in this case, we're just generating data to work with. These are 5 different prompts, each one for one of the generated people. And then at the end, we integrate with S3. So if you were to think like how much AI did I need to know to create this, it was basically none. It's super developer friendly. You can see that we have a Bedrock invoke model integration right here. So in fact, I created all of this via the console. I didn't have to write a single line of code. It was able to generate some data for us. Here you can see you can choose the model. I'm using the AI21 Mid. We're going to see a little bit more later about these different models. So that's the first POC. I've done this completely via the console. No code was necessary, and it integrated very well with step functions and S3 for us to generate and imagine some data. Now, the next one is a bit more complex. It's a generative API POC. And when would you want to use something like this? Well, the idea is that I had was how can we speed up development, so initial development or prototypes or POCs using generative AI. It came to my head that many teams when they're starting projects, they might have limited people in the back end and more people in the front end, or they just have a scope that's too large for everyone to implement. So you can actually try to be creative and use AI to create an entirely fake backend. So let me show you how that works. So let me show you here the architecture diagram. This was very time consuming to make because there are too many services involved, but we had API gateway, step functions, and Bedrock, and that's all. No need for VPCs or any other complexity. Everything is serverless. And let me show you how it works. So in this API, we have 3 endpoints. We have a list of campaigns, a get one campaign, and a post campaign. And if we run the /campaigns, since we have an integration directly between API gateway and step functions, we get a pretty verbose output containing all the details from the step functions. So we have to look at the output, and that's what came out from the step function we just ran. And so you can see that when I requested /campaigns, the AI imagined for me what that output would be. So we have a UUID, which is just a bunch of numbers, a name, a start and an end date, and an is active true. And how did we get to this result? Well, it was basically using this prompt. I told the model that you are an API that handles campaigns. based on the input received, provide an appropriate response with a RESTful API would give. Return always a valid JSON, no extra information. I gave it which are the required attributes. And you can see that I didn't specify any data types. I just said UUID, name, date, and is active. And for the model, that was enough to know that this is active was a Boolean, that this end and start date were date fields, and that this was a string. Also told that you would allow post and get, and these are the allowed paths, and the user input is, and then whatever we pass through is the input. We can see, for example, the post, which is a little bit more complex. We're passing in the request body. So one interesting thing that happens is if I say new campaign is active true, start date, and send this request, and we take a look at the output, we got, it didn't understand what the UUID should be, but that's okay. We still got the new campaign in the right place. The start date matches the date that I passed, and it even added the rest of the timestamp that should be there. The is active true was also done correctly. If we say is active false, that's also going to give us an okay result. Let's see, output, yeah, the is active becomes false. So that's pretty interesting. And let me show you here the, yeah, I mean, it's pretty much an experiment. So the data is all generated by the AI. There's no real backend, but the thought experiment that I wanted to do here is how effective would it be to start a new project, and instead of going through code prototypation, what if you just gave it functional requirements? So you just think from a high level what the API should be, and you let the AI handle until the front-end team can implement the integrations. And then later on, you do the real implementation. So this might speed up development for some teams. And you might think that this AI is too unpredictable, and it all depends on what's the temperature level that you set. In this case, I've set 0. And so 0 means don't be creative. Give me always the same output. So for my example, that's what I want, because I want the API to be somewhat consistent. For different use cases, you want the temperature to be high to get creative responses, such as the previous example. So yeah, using this setup, you can even get an API specification if you want, and your entire backend is fake for some time until you get to the real implementation. I think this is a pretty interesting experimentation. And if you also want to take a look here at how Bedrock itself looks like, each model, you have to make an explicit request to use it. I've selected just a couple. I've selected let me show you. I selected and I'm using these two mainly, the Jurassic to Ultra and Mid. And we can change it if we want. And we're going to get different results, and you can play around which model works best for you. So in this setup, as soon as I save, it's going to publish and update my step function, and our backend is going to change completely. Now, the same thing is if we change some field here, it's going to reflect, takes like 15 seconds, and it's deployed. And now if we call, for example, let's call the get list of campaigns. Now we're using the Ultra model, so it takes more time to get a response. And you can see it's pretty similar. So yeah, do you have any questions or comments?
What about costs of what about the related cost of the service and the usage?
So when it comes to Bedrock, Bedrock is only an interface, so it doesn't have its own cost. You're paying for the underlying model. So let's take a look here. So one of the things you can do to change your cost is by provisioning throughput and making a purchase. So This way you pay more per hour instead of paying per token. If you don't set up, such as the way that I'm doing, I'm just paying for the amount of tokens that I request. And so each model is going to have its own pricing. So let's take a look here, the pricing. So this one that I'm using, since I'm paying per 1,000 tokens, that's the cost that I can expect for each different model. And you have the full detail here, but it's definitely something that gets expensive at scale. So you have to be careful on how you use it.
Okay, and can we know about the cost of this usage? Because in the second example, you created a kind of mock of an API, fake responses, and in order to get that result, how about the cost
Yeah,
of that experience?
Yeah, in that example, let me see if I have from my tests of yesterday, I might have some costs. It was less than $1 for me to test. So you kind of multiply that by how many people you have testing that API. Let's see here. I don't think it got any significant cost because it was such a low scale from the tests that I was doing.
So the model and the step function will work on each request and will have an associated cost, at least in the way that you are showing us.
Yeah, exactly. You're going to pay with the API gateway, you're going to pay for each token on demand that goes out of the model, and you're going to pay for the step function invocation. Yeah, my cost was pretty much nothing for these tests. Yeah, but it's completely up to you. This is definitely not cost effective since it's meant to be guided for developers. There's nothing I can do to optimize unless I explicitly ask for less tokens or you provision the throughput. Another way you can make this very expensive is doing a custom model where you fine-tune the model. This should give you really good results, but then again, you're training. So this specifically is going to be costly. Yeah.
All right. So in this example, and as a very quick summary, you show us a new service with the name Bedrock that allow us to manage the different models that we have available and different sources. AWS has its own source of models that we can use. The models have different costs and as well the service. And what we can do with the model is to integrate with applications. In the example, you show us a step function and some code that use the Bedrock service, and you show us that you integrate the step functions in this UI. This way you are enable a process where you connect Bedrock in some way and just link the code to, okay.
Yeah, it's pretty interesting. Like if you think you have an entire backend that is completely imagined by the AI, and you're just using 2 steps to make that happen and a prompt. If you want to optimize, you definitely can refine this prompt and also make this prompt behave per route. So get route should have its own prompt, post should have its own prompt. In this case, I have a single prompt for all the actions that the API might have. So the quality drops a lot, but the implementation is super quick. The implementation is a single file, one prompt, and the integration itself, it's a balance between, how specific you get. The more specific you get, the better the result is. Because at the end, this model is going to generate whatever you ask. So it doesn't think like us humans. It's only like a statistical approximation of what it thinks is the right output for your prompt. So making something generic like this is not as good as making one prompt per route. So that's an easy way to improve this setup. But what is interesting is that even something super simple, one prompt, can actually give you convincing enough results that you have an API when you actually don't. It's all made up by this AI.
And Marcelo, this file, I'm sorry, I'm not aware about implementation of step function, but here you have a TypeScript file where you define the model, the prompt. That's the way to connect with the model. And that state machines is represent what we are seeing on the other screen, right? With the diagram in the step function, right?
Yeah, the step function you can think of it as, so it's a state machine. You define a schema and you define how the state is going to across each step. So in the first step, I have the Bedrock invoke model. I have a parameter where I can specify the model. So you can see I change here from ultra, mid, llama, any of the available models, and we replace here in the substitutions. And I do the same thing for the prompt. We define up here in the code, and it gets replaced in the step function. You can do that process with anything. You can have the temperature outside of this JSON file as well. And what I do is I take the response from Bedrock, which is a big JSON object, and I want just the text, just the output, and I pass it to the next step, which I transform that output into a JSON. So if the model fails to create a JSON for me, this step breaks. So with step functions, you can have a catch mechanism to retry, or to put this failure in a dead letter queue. In this case, it's so simple that I didn't bother, but that's pretty much the entire implementation. And then for you to connect an API with step function, yeah, go ahead.
No, sorry. And first you tell us that you didn't write code, so all these files were generated by the UI that you show us at the beginning in the step function.
Oh yeah, there were two POCs, right? This one, the integration with S3 that I showed you in the beginning. This I did it all via the UI. I did no infrastructure as code. I didn't write this. I just used the designer tool to create the step function. And you search for Bedrock and you copy paste here. So that was what I did. But after this, I wanted to do something more complex. So I kind of came here, took this code, and I went into VS Code and started working in this POC. Then I use CDK and SST to declare the step function. So I use code, infrastructure as code in this part, in the API, but not in the story that goes into S3.
I see. Perfect.
Yeah.
Well, amazing.
Yeah, it's very interesting. Yeah.
It was awesome, really interesting to see this working. I have two questions. One is, if I want the API to be like, I want to say to the model, I want a specific format, so I force the format to be generic and not that dynamic. We could do it now, like to force a certain JSON format. You could do that, for example, in the prompt.
And schema, you mean?
Yeah, I mean, if I want to restrict the API more and more to be more constant, that's something we could do.
You can try. Like you're gonna have to test and see what comes out, because in my test, like I got to this prompt because as you go along, the AI is gonna add a bunch of stuff that you don't care. So one of the things, you have to set the temperatures to 0, because otherwise you're going to get more creative responses, and these responses can break the JSON schema that you ask, and the AI may forget things. So if you put the required attributes at a certain position and you start telling it other stuff, it's going to forget. It has a limited memory. If you use the Open API integration, which is outside of AWS, they allow you to specify a JSON that you want, guarantee JSON. I don't know if the Bedrock service has that, but if it had, eventually you could say that you always want the JSON, but the format itself, the content, is not guaranteed.
I see.
Yeah.
Interesting.
Yeah.
And my second question is, where we can read about this stuff, like where did you research for this, or where to go next to to keep learning about these tools.
For sure. So I'm going to share in the channel a couple of things. I can share the code that was used to create this fake API. We have the example here, so you can run in your own AWS account and see it working. And I recommend going on YouTube and searching for AWS Bedrock. You're going to see lots of new things that are happening. We're launching new integrations. So the big inspiration that got me to do this OTT is because just this week they released this Bedrock Invoke model integration on step functions. So before this didn't exist. And this week we can start invoking this model without even knowing the SDK. You don't even need to care about the SDK itself. You can just go in here and then pull it to the step function and start using. I think those are the resources that I recommend in YouTube. There are lots of new talks going out during the reInvent that talk about this service.
Okay, great.
Marcelo, and you talked at some point about the vector database. Where you define somewhere how does the vector works here in terms of the model and where the near neighborhood or something like that.
Yeah, as far as I know about this, the knowledge base, let me see if I can move forward here. S3 setup data source. So one thing that I saw in one of the talks is that you can hook this up into, for example, OpenSearch serverless. So if you want to keep your stack serverless, let's see, quick create new vector store. That's the recommended path. They say they're going to create for you. And this is also a new service, the OpenSearch serverless vector store. It's going to create in your behalf, and your vector store is going to be all managed by Bedrock. So you're not going to actually see it. You also have the option to choose your own, right?
Sounds like the Elasticsearch, because OpenSearch is the Elasticsearch implementation. So looks like they are using the SRE, maybe.
Yeah, it's just an abstraction. So to make it easy and fast for developers to have a vector store, which they call it knowledge base, you just go through this UI and they create it for you. And it's probably going to be pricey compared to doing your own, setting up your own OpenSearch. But yeah,
right,
it's an option.
Oh, nice.
Yeah.
Pretty awesome. Thank you.
Thank you. Right. Yes, we can call it an OTT.